The Pythagorean theorem is the assumption or theory that a squared plus b squared equals c squared. That looks like it might be a little difficult to realize, but when we talk about right triangles, you have two legs, which are right here, and we're going to assume that this is A, and this one is B, and this one is C. Now, where that squared part is coming from is from here. Let's say that this is our A again, just drawing it down here because I have a little more room. This is B and this is C. Let's say that we had a square where all sides were B. We had a square, that doesn't look like a square, but let's just assume that all of these sides are equal and they're A. Now, if we added the area of this square, if we added the area of A, which is a square number, plus the area of the B, or B squared, it would equal the same area as the area of C, or the C squared. That being said, let me make this a little easier for numbers. You have, let's do a 3 and a 4, and this one will be 5. So our A is 3 and our B is 4. We're going to make a square off of this B. So a square, all four sides are the same. So that means this is 4, this is 4, this is 4, this is 4. The A leg, this is 3, this is 3, this is 3, this is 3. And when I add up the area of this plus the area of this, it should give me the area of a square coming off this hypotenuse. So the area of B is 4 times 4, because you just take your sides squared. The area of A is A squared, or 3 times 3, and that equals 9. The area of B squared equals 16. Now, with the Pythagorean theorem, what that's saying is if I added 16 plus 9, it should give me the equivalent, or the equal value of the square coming from the hypotenuse. So that is 5 times 5, and that's our C. Which is 25. So this is just explaining where these numbers are coming from. This is why you have the A squared plus the B squared. So we squared the A, squared the B. You got 9 and 16. I'm going to write this over here. I'm sorry, this is so disorganized. We have 16 plus 9, and you get 25. And ideally, that 25 is going to be the same value as your hypotenuse. Now that proves the Pythagorean theorem, but now we actually have to put it into practice. And if you need to rewind this and go back and make sense of this, please feel free. If you have any questions, let me know, because this can get pretty tricky. But I just wanted to explain where the Pythagorean theorem came from, why you're squaring numbers, and how you get what you get. So, with some more common problems that we do, I'm just going to write the Pythagorean theorem up here. we have let's do, in one of the problems, you have an A, oops, you have an A, I'm sorry, your A is on the side. We know that A is 12, and in this one we have C, which is 13, and the B is the one that we don't know. So really, you fill in, you plug what you know into your equation. We know that A is 12, and that we're still going to need to square it, plus B we don't know, so we're going to leave it B, equals 13, and we need to square that as well. So the goal with any equation when you have a variable is you want to isolate this variable. We do that by subtracting 12 squared from both sides. And I'm not squaring anything now just because I like to do it at the end. So now I have b squared by itself equals 13 squared minus 12 squared. Now I'll go ahead and find my values for 13 squared. 13 times 13 is 169, and 12 times 12 is 144. And we'll carry that down just to keep things consistent. And 169 minus 144 is 25. Now you still have this pesky square here with the b that you have to get rid of. You get rid of a square by taking the square root. So you have, if you do it to one side, you have to do it to both sides. Take your square root of 25. Now you have b finally by itself, and the square root of 25 is 5. Now I think the question in the book asked you to find b squared, so you would stop at this step right here. So b squared is actually 25, and then b is 5.